All right, so for this lesson, we're going to look at conductors and insulators, and in-betweens are basically, my pen. It's the wrong color too. And the in-betweens, okay, very good. Okay, that's fine. Okay, so in-betweens are basically also known as sometimes semiconductors. So meaning it's not really a full conductor or a full insulator, but we'll get to that. And we're also going to add on a small section looking at units of electric charge. We're going to get into, in the next section of electricity, calculations involving charges. So I just wanted to go over what we mean when we say electric charge. That way it's just going to be more familiar when we actually get to using them. Okay, so conduction and conductivity. So conduction, the term conduction is basically talking about the movement of electrons. So if we have a material that is able to conduct, that means electrons are able to flow through it relatively easily. So actually we saw this in chemistry, right? We know that metals are able to have electricity move through them. So metals are allowing for conduction to occur. So conductivity is the ability of the substance to allow electrons to move freely in them. So they're very similar. So conduction is the actual movement. Conductivity is talking about the ability of something to be able to have electrons move in them. So this is actually a type of physical property. By us saying, okay, metals have conductivity, we're describing the physical property of that substance. So even though you have a whole bunch of different metals that are able to conduct electrons, sometimes they're not always the same. So some metals have lots of conductivity, like a high level, and some are not. Even though they're conductive, they're not as easily conductive as others. Okay, so the higher a substance conductivity means, the more easily electrons are able to flow through them. So basically, the higher the conductivity, the better of a conductive material it happens to be. Okay, so just for example, silver is actually the highest conductivity of all the metals on the periodic table. So even though things like copper and lead and iron and nickel and zinc, those are all conductive, silver has the highest conductivity. So even though metals are conductive, there are different ranges of conductivity that exist. Okay, so insulators. So an insulator is the opposite of a conductor. So it's something in which electrons cannot move freely from atom to atom. And actually, all of the materials that we look at in static electricity are insulators because electrons don't freely move. They can go from one object to another. So we can have electrons jump from plastic to rubber or from silk to wood, but we can't have them freely flowing. Okay, so they don't move freely. So static charges build up on these objects and they can transfer, but it's not going to be a free flow movement like it would be in a conductor. Okay, so like I mentioned, what's a conductor? It's a substance in which electrons can move freely, so basically all metals. So the charges don't build up on these objects because electrons can flow through them, right? So it doesn't stay in one spot. It's not like a balloon where if you rub one side of the balloon, you end up having a buildup of charges. What happens is the electrons don't build up because it just continues moving through. So the in-between or fair conductors, or sometimes they're referred to as semiconductors, these are objects that are not really great at anything. So they can conduct a little bit or they can insulate a little bit, but they don't really fall into one of the two main categories. So some examples. So soil is a semiconductor. So is carbon. So is actually silicon. Okay, so is actually humans also, but we're mostly carbon-based, so that kind of makes sense. So that means that electrons can flow through them, just not as easily as it can in a true conductor. Okay, so for example, the carbon that's in your pencil lead, which is known as graphite, is a semiconductor. So the pencil lead itself can actually move charges, just not as well as a metal would. Okay, so there's actually a long list of conductors, insulators, and the in-betweeners in your textbook, so if you want to check that out. Okay, so the last thing, and it's just one little piece here, is just talking about units of electric charge. So when we talk about electric charges and movement of charges, you have to remember that electrons are very, very, very small, and they're very, very, very light. And we saw that when we looked at atoms. So what we do in science, typically, is we cluster electrons together. So instead of looking at electrons individually, we look at electrons in little packets or little groupings. So we call that unit, this little grouping, a coulomb. Okay, and it's named after a scientist. So coulombs we represent with a capital letter C. So 1 coulomb, so remember I mentioned this is like a little packet. It's like a package of electrons. So we cluster them together. So the clustering of electrons is actually a huge number. 6.24 times 10 to the 18. Now we've seen this scientific notation before. So really, this means the decimal point has been moved 18 times. Let's see, is that even enough? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Okay, so that's huge. So this many electrons, so remember, they're so small, like they're so small and they're so light, right? It's a huge number, but we equal this to 1 coulomb. It's way easier saying 1 than it is to say this big number, okay? And when we get into calculations, it's going to be easier to calculate with the number 1 than putting this number in our calculator. So this can change too. So let's say I had 5 coulombs. That's like I have 5 packets of electrons. So it would be 5 times this value. Right? So I'm just introducing you to this idea of coulombs, right? So what does a coulomb mean? It's essentially a cluster of electrons that we use to make life easier when we're looking at electric charges that are moving. Okay, and this will make more sense once we get into the part where we're going to be using calculations involving electric charge.